Hello everyone. Welcome to Vardhaman College of Engineering. I am Dr. A. Kishore Kumar, Assistant Professor, Department of Chemistry. In Engineering Chemistry course, we have water and its treatment. Today we are going to cover numerical problems on hardness. So calculation of hardness of water. We will be given certain data of hard water sample. So here you can observe calculate the temporary and permanent hardness of water containing following salts. Here magnesium bicarbonate, calcium bicarbonate, magnesium chloride and the calcium sulfates are given, and their weights are given. So here few things first we need to follow. So first we need to convert these weights into calcium carbonate equivalent weights, right? So whatever the weights are given, so this is the amount of magnesium bicarbonate and this is the amount of calcium bicarbonate, and 9.5 mg per liter is the magnesium chloride's amount and 13.6 is the calcium sulfates amount, right? So first we need to convert into calcium carbonate equivalent weight, right? So yes, in next slide you are going to see what is the formula here. So before that, why we need to convert into calcium carbonate equivalent and why we are choosing this calcium carbonate as a reference salt. Here first reason is calcium carbonate is the most insoluble salt. So this is the most insoluble salt. Calcium carbonate is the most insoluble salt. So that is one reason. And second reason is its molecular weight. Its molecular weight is 100. So which is good to use in numerical problems, right? By considering these two reasons, we are choosing as a calcium carbonate as a reference salt, right? And first we need to convert the given weights into calcium carbonate equivalents, right? And next thing is we require molecular weights of given salts. Molecular weights of given salts, right? So in most of the cases molecular weights will be provided for the given salts. If molecular weights are not given, right, then we need to go for calculation of molecular weight of the given salts, right? So here for example hydrogen is given, for example if hydrogen is there, right, so its molecular weight, if its atomic weight is 1, if carbon is there, right, its molecular weight is 12, right, chlorine is there 35.5, right, sulfur is there 32, right, for nitrogen 14, for oxygen 16, right, calcium 40 and magnesium 24, right? So if you know the molecular weight, right, of individual element, then you can calculate the molecular weight of the given salts. So most of the cases you will be provided molecular weights of the given salts. If molecular weights are not provided, then by using that information you need to go for calculation of molecular weight of given salts. Later another important point is first you need to identify which salt is a temporary hardness causing salt and which salt is a permanent hardness causing salt. In previous session we have discussed which salt is a temporary hardness causing one and which one is a permanent hardness causing one, right? So after that, so total hardness means temporary plus permanent hardness, right? And temporary hardness causing are what? Bicarbonates of calcium plus 2 and magnesium plus 2 salts, right? That means calcium bicarbonate and magnesium bicarbonate. So permanent hardness, so chlorides, sulfates and nitrates of again calcium plus 2 and magnesium plus 2. That means calcium chloride, calcium sulfate, magnesium sulfate and calcium nitrate and magnesium nitrate, right? So like that, first you need to identify which comes under temporary hardness causing salts and which comes under permanent hardness causing salts. And one more important point, if in the given data here 4 salts are given, if calcium carbonate is given, so we should add that calcium carbonate in a temporary hardness causing side, right? So calcium carbonate comes under temporary hardness causing salt. And sometimes they will give KOH sodium hydroxide. So sometimes they will be providing what KOH weight they will give, sodium hydroxide weight they will give in the given data, and even organic matter, organic matter. For example, KOH 5 milligrams per liter is there, NaOH 10 milligrams per liter is there, and organic matter 20 milligrams per liter is there, right? So like that they will give, right? So if you observe these salts and organic matter, so don't go for calculation or conversion into calcium carbonate equivalents of these things, because they will not contribute any hardness to the water, right? Yeah, let us see here formula. Calcium carbonate equivalent weight, right? So calcium carbonate equivalent weight is equals to mass of hardness causing salt into molecular weight of calcium carbonate. Here molecular weight of calcium carbonate is 100 by molecular weight of hardness causing salt, whatever the salt is given, right? Let us see one problem. And before going to problem, so molecular weights of the salts you can observe there. Calcium bicarbonate 162, magnesium bicarbonate 100 for calcium carbonate, 84 for magnesium carbonate. For magnesium chloride 95, calcium chloride 111, calcium sulfate 136, magnesium sulfate 120, calcium nitrate 164, magnesium nitrate 148. So here let us discuss which comes under temporary hardness causing salts and which comes under permanent hardness causing salts. So here calcium bicarbonate, so temporary hardness causing salts I am abbreviating with T, right? So calcium bicarbonate temporary hardness causing salt, magnesium bicarbonate temporary hardness causing salt, calcium carbonate as we discussed just now, so we should consider this as a temporary hardness causing salt. Magnesium carbonate again temporary hardness causing salt, magnesium chloride permanent, calcium chloride permanent hardness causing one, calcium sulfate permanent, magnesium sulfate permanent, calcium nitrate permanent hardness causing salt, magnesium nitrate also permanent hardness causing salt, right? So let us see one problem. Yeah, so problem number 1, calculate the temporary and permanent hardness of water containing magnesium bicarbonate 7.3 milligrams per liter, calcium bicarbonate 16.2 milligrams per liter, magnesium chloride 9.5 milligrams per liter, calcium sulfate 13.6 milligrams per liter. So they are asking what temporary and permanent hardness they are asking, and the given data is there in milligrams per liter. That means answer also you will get in milligrams per liter only, right? So what we should do, first we need to go for what, conversion into calcium carbonate equivalent weight, and the formula is mass of hardness causing salt, molecular weight of calcium carbonate, and the molecular weight of hardness causing salt, right? So first here conversion into calcium carbonate equivalent weight. So first salt is a magnesium bicarbonate, right? So we are converting magnesium carbonate's weight into calcium carbonate equivalent weight, right? So magnesium carbonate molecular weight we should know, right? So magnesium carbonate's molecular weight is 146 and the given weight is a 7.3, right? So 7.3 by 146 into 100, so we are getting 5 milligrams per liter. So next salt, calcium bicarbonate, its molecular weight is 162 and its given weight is a 16.2, right? So we are getting 10 milligrams per liter. So like that for next salts also, yeah. So magnesium chloride, so 95 is the molecular weight and given weight is 9.5, so 10 mg per liter we are getting. And calcium sulfate given weight, given amount is a 13.6 and its molecular weight is a 136, we are getting 10 mg per liter. So like this, first we need to convert into calcium carbonate equivalent weights, right? So after converting into calcium carbonate equivalent weight, next we need to go for what, calculation of temporary and permanent hardness, right? So first we need to identify temporary hardness causing salts, right? So in this data, two salts are responsible for temporary hardness causing. Those are what, calcium bicarbonate and magnesium bicarbonate, right? So here 5 mg per liter for calcium bicarbonate and 10 mg per liter for magnesium bicarbonate. So total we are getting 15 mg per liter, right? So next step, permanent hardness, right? So permanent hardness causing salts from this data are magnesium chloride, calcium sulfate, right? For magnesium chloride, after conversion into calcium carbonate equivalent, we got 10 mg per liter, right? So 10 mg per liter. Next, for calcium sulfate also we got 10 mg per liter. So permanent hardness, that means what, total permanent hardness is 20 milligrams per liter, right? So total hardness now, permanent hardness plus temporary hardness, so 20 plus 15, we are getting 35 mg per liter. So like this we need to do calculation of hardness. Let us see another problem here. A water sample from an industry had the following data: magnesium bicarbonate 16.8 mg per liter, magnesium chloride 19 milligrams per liter, magnesium sulfate 24 milligrams per liter, calcium chloride 11.1 milligrams per liter, and calcium carbonate is given. Calcium carbonate 20 milligrams per liter, potassium hydroxide is given 20 milligrams per liter. As we discussed in previous slides, whenever you find potassium carbonate, don't go for conversion into calcium carbonate equivalent weights, right? Because it will not cause any hardness. It will not cause any hardness, right? And calcium carbonate is given. So whenever calcium carbonate is given, that we should consider as a temporary hardness causing salt. This is a temporary hardness causing salt, right? First, let us identify which are temporary hardness causing salts and which are permanent hardness causing salts. Magnesium bicarbonate, it is a temporary hardness causing salt, right? Magnesium chloride, permanent hardness causing salt. It is permanent hardness causing salt. Next, magnesium sulfate, also permanent hardness causing salt. Calcium chloride, also permanent hardness causing salt, right? So in this data, permanent hardness causing salts are 3: magnesium chloride, magnesium sulfate, and calcium chloride, right? And temporary hardness causing salts are 2: magnesium bicarbonate and calcium carbonate, and KOH will not cause any hardness, right? So now we need to go for what, calculation of temporary and permanent and total hardness, right? So use the formula, right? So calcium carbonate weight is equal to mass of hardness causing salt into molecular weight of calcium carbonate by molecular weight of hardness causing salt. Thank you.